All right, here we go. I guess I could title it, Parametric. So this is something you have not seen before, right? I don't think anybody in here has seen parametric functions before, have you? No. Everybody's here today? Oh, Josue. All right, tell me this. What is a relation when we're talking about mathematically a relation, not any other type of relation? Give me an overview. What does it mean to be a relation? No, not a relationship. A relation is any set of points, any set of, we'll say, x, y points. They have two parts. They have an x and a y, right? They form a relation. The x influences what value the y is going to have, right? All right, so then we can take these relations and we can set a parameter on them. Do you know what a parameter is? It's like a bound. You're exactly right. It's like a boundary. It's a good job. It's a fact. We're going to say that it's a factor that points. A factor that influences or changes or restricts, things like that, influences the relation. No, we're not going to use it. We will use it in a sentence. Let me finish defining these three things. So we use parameters to define a parametric function. Okay, that root word there is parameter. So we're talking about some things that are going to limit our function. So let's see. Your variables, what variables do we always use? X and Y. So your variables X and Y are now subject to a third variable that we're going to call, you ready for this? Somebody's timer's going on. A third variable we're going to call T. Okay? And I think the best way to understand this, it's really not hard, is just to show you an example and you follow through it. It's really, really not hard. All right, y'all tell me when you got that and we'll jump in. Here's the first example. Here's how we define parametric equations. We're actually, instead of saying y equals some x, we're going to define x and y using t, using those parameters, okay? So we'll have x equals, we'll say t minus 2, and y equals t squared. So here, these are my parametric equations, okay? So here's what we're going to do. We're going to make a table. And we're going to do this for different values of t. And we're going to plug it in for x, and then for y, and then we're going to put x and y together to make a point. Okay? So we're still just graphing points. It's still going to be, this is really, really, really not that hard. Hopefully, it's not that hard. It looks worse than what it is. I'm going to go from -3 to 3. And I'll give you just a second to catch up with me. Yeah, we're going to plug all those points in. But look how easy the equations are. The first one is t minus 2. The second one is t squared, right? No. We are starting out easy, but they're not going to be too bad. But I am going to show you how to do it on your calculator. All right, so when we plug it into x, so I'm referencing this equation here and this one here. All right, I'm gonna plug these values in for t in the x equation first. So negative 3 minus 2 is what?
I don't know.
Yes, negative 3 minus 2.
Negative.
Oh, it's Monday morning. Negative 3 minus 2. That's saying x of t. Remember we talked about f of x, g of x. This time we're plugging t into the x equation. How about y of t? So y of negative 3. It's 9. Right? Exactly, Cameron. That's perfect. Negative 5. 9 is the point that you would graph for this. All right, try negative 2. Negative 2 minus 2 is... Y'all put it on. Negative 2 squared. So this one is negative 4. How about negative 1? What is x of negative 1? Negative 3. How about y of negative 1? Woo! What's the point? Negative 3, 1. How about 0? Negative 2, and so the point is easy so far? Getting better? I told you the easiest way to understand this is just to do it. How about if I plug in 1? Negative 1 and 1. There you go. Now this is 0. 2 minus 2, you're correct, is 0. 2 squared is... So the point is 0, 4. And one more. 3 minus 2 is 1. 3 squared again is 9. So I have 1, 9. So when we graph this parametric equation or parametric function, literally we are graphing these points. Let's graph it first, okay? And let's see what it looks like when we graph it. Is it a parabola? Probably. I don't know. Let's see. All right. Negative 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Negative 5, 9. Negative 4, 4. Negative 1, positive 1. It is a parabola. Nice. Questions so far? Well, I'm going to show you how we get the equation without the parameters. So are y'all ready? Yeah. So the first thing we did, right, was we found the points to graph. So the first thing essentially we did was we graphed the parametric function. All right. The second thing we're going to do is we're going to write an equation of the parametric function, but we're going to do this without including the t's, okay? It's called eliminating the parameter. Eliminating. So essentially, we're going to write an equation of that parabola we just graphed. Okay? So to do that, let's go back to what we started with. We started with two equations, right? Come on. We started with an x equation and a y equation. We all agree? Okay. What we're going to do to write this equation, the first thing we're going to do is we're going to solve the x equation for t. So if you solve that first one for t, what do you get? What does t equal? Do we all see that? If we solve this equation for t, it means we get t by itself. So we add 2 to both sides. So t equals x plus 2, right? Are y'all with me? Okay. Hold on. All right, so always the x equation, always solve for t. Now what we're going to do is we're going to take this and we're going to plug in for t in the y equation. And this is going to give us our new equation. So here's my y equation, right? Y equals t squared. But instead of t, I'm going to put x plus 2. Guess what happens if you graph y equals x plus 2 squared? What parabola might you get? You might get, actually you will get, that parabola. Yeah. Let me show you, take out your calculator really quick. Let me show you on your calculator how we're going to do this, and then I'm going to do another harder example. Yay! Y'all going to have to control yourselves now. What is going on with y'all this morning? Y'all are staring at me so solemnly. Yeah. Let me record this. All right. If you go into your calculator, it will look different than that.
Why would he not see?
All right, listen, you got to follow these steps exactly or else it won't work, all right? So we're going to graph this parametrically. So what you're going to do, if you hit the button that says mode, do you see down where it says function, there's the option for PAR, POL, or SEQ? You're going to choose PAR for parametric. Mode, enter, yep, hit enter once you're over it. It's down to the 4th row and over to the 2nd one. All right, now when you go into y equals, notice it looks different, right? So what you want to do is you want to put your two equations in here. So it's going to automatically, your variable is automatically going to be t. So if you hit the x button here now, it's t because you're in parametric mode. So t minus 2 and then t squared. Okay, we're going to zoom 6 on it. Mode. All right, so several of you, if you hit window, you need to change your t, min, and max. Okay? Because remember, we plugged in -3 for t up to +3, so you might want to change that from -3 to 3. Did you put this on the notes? Yeah, this is in the notes. This is in the notes. Okay. As far as changing to parametric mode. All right, listen, remember we did zoom 6 for zoom standard? If you go into your window, remember when we plotted these? Let me go back to my original page here. Come on. We took our t values from -3 to +3. Right? Graph it. Your graph looks like what we got. So what I was telling you before all that messed up with the printer, if you hit window, your t, min, and max, whatever you went, your values of t that you plugged in originally in our t chart, right? Remember we went -3, -2, -1, 0, 1, 2, 3. So we went from -3 to 3. So I changed that here from -3 to 3. Okay? And so your biggest thing whenever you're looking is that your graph matches what's on your calculator. All right? We'll practice some more with it. Let's do one more example. I think we're going to stop at parametric functions today. We'll do inverse tomorrow. That's all there is to parametric for right now. So let's do another. What?
Let's try that again.
What? What? Let me. Let's do this one. Ah! Tell me what to do first. Table. Table. Actually, I'm not starting out with X. T. And then I'm going to do X of T, and then I'm going to do Y of T, and then I'm going to find my points. I'm thinking this one might be a parabola again. What might make me think that this might be a parabola? I'm going to plug something in for these T's. Yeah, try it by yourself. Go ahead, Mars. All right, I'm going to start working it as y'all finish up. -3 plus 2. And I like to write, sometimes I'll come over here and say this is T plus 1. This is T squared plus 2T. Come on. I got -2, 3 for my first point. Is that what y'all got? I'm gonna guess whenever you squared it, you have to, you got to put it in parentheses. So you have to do -3 squared.
When you square it,
That's right, Jerome.
So wait, what did that mean?
you made it negative.
When you square a negative number in your calculator, it needs to be in parentheses. -1 would be 1 plus negative. Oh, look, I messed up on that one. Nobody's going to catch it?
It's 2.
It's 4 plus -4, which is 0. And this is 1 plus -2, which is -1. Plug in 0, you get 1. Plug in 0, you get 0. Somebody's going to have to call these points out to me whenever I go to graph them. 1 plus 1 is 2. 1 squared is 1 plus 2, which is 3. You can see the reflection happening here, right? 2 plus 1 is 3. 2 squared plus 2 times 2. So this is 3, 8. And then 3 plus 1 is 4. Come on. 4 squared is 16. Oh, not 4 squared. Silly. 9 plus 6. You can't do this? Or are you just saying in general you just... All right. Now all that's left is to graph them. Then we'll look at our calculator, make sure we got the right thing. All right, I'm still in parametric mode, which is good. I'll just go in here and do my t plus 1. What was the other equation? Plus 2t. Let's graph it, make sure we get the same thing. If I kept my t going further down, it would have the whole parabola on there. All right, let's do the graph. -2, 3. What else? -2, -1, 0. Ooh, way up there. All right. Yes or no with parametric equations, parametric functions. Y'all want to move on to inverse? You want to save it? Look, we forgot to write the equation without parameters. I'm sorry. Let me go back. I want to make sure because I'm going to have you do that on your homework. So take these two equations, t plus 1. We're going to do it together. X equals t plus 1. Ugh. And y equals what? T squared plus 2t. Solve the x1 for t. So t equals x minus 1. Exactly. Now this, subtract 1 from both sides. This is going to go in for all the t's here. So you got x minus 1 squared plus
That's it?